So I want to start by saying, who doesn't like maths? Right, okay, who likes maths? Okay, well, for those of you who don't like maths, I'm going to show you today an interesting application of why maths actually could be really way more interesting than you think it actually is, and could be really well worth investigating. So my name is Charles Paxton from the University of St Andrews on the other side of the country, and I'm a type of biologist called an ecologist, which means I'm interested in kind of populations and what eats what, and all of those sorts of questions about animals. And my proper job involves estimating the number of whales around the world, around Scotland, off the coast of America, all sorts of different places. But I have a hobby, and my hobby is the science of sea monsters. And as part of that, I try and use the same methods I use in my ordinary job, but apply them to monsters. And that may sound a really crazy, stupid thing to do, but actually it can tell us some really, really interesting things. Next slide. Oh, have I got the power? Oh, I've got the power to do that, right. Okay. Here we have three images of monsters. We've got the famous photographic image of the Loch Ness Monster, and that's a sea monster from the Renaissance times called the Xiphias, and the Great Sea Serpent. Oh yeah, do we think? No, it's not going to work. Okay. If you go on the BBC Earth channel, you'll see another story about how you can apply statistics to estimate how big giant squids get. I haven't got time to talk about that story, but the BBC did a lovely video about it, so have a look at that. Now, we've already established that monsters should be big, and it's very important as a scientist that you define all your terms, and so the monsters, from the point of view of my talk, are going to be animals greater than 2 meters long, which science has not discovered yet. So that's my criteria of what is monstrous. So 2 meter long animals, about 7 foot for the people who use older units. That's bigger than a human being, so they can eat them and all that kind of thing. So we're being consistent in our terminology here. So that's my definition of monsters. Beings greater than 2 meters long, undiscovered by science. And I'm then now going to say something really quite surprising, which you might find very surprising for somebody working at a university in a professional capacity to say. There are monsters out there. And I say that really without any doubt whatsoever. And that seems a pretty staggering claim for someone like me to make. Will I get thrown out of my university? Well, I don't think so, because I've got good evidence for a claim like that. And this is the evidence. Oh yes, we've got to identify our questions. As scientists, we have to identify our questions. And that's the question we're kind of asking. Are there large marine and freshwater animals awaiting discovery by science? So that's the question. I think the answer to that question is a very definite yes. Maybe not in Loch Ness, but certainly somewhere around the world. And this partially is the reason why I think it's true. We're still discovering large marine animals greater than 2 meters long. And here are some examples. Orchella hessoni, discovered in 2005, a new species of porpoise. Balanoptera murei, it's a baleen whale, described in 2003. That one's probably not an entirely new discovery, because actually it was distinguished using kind of genetic methods from existing species. So I'll concede that's probably not a new species. Mesoplodon perenni, it's a new type of whale, a beaked whale. Beaked whales are very mysterious whales. We don't know much about them. They dive to great depths and they eat squid. That one was only described in 2002. Bathyrardia haspriafricanus. There aren't common names for these animals because they're so recently discovered. That's a giant ray discovered off the coast of Africa, only in 1995. Regulucus kinnoi, a bit of a controversial one, that one. That's a type of fish called an oarfish. Could be a very, very long, thin, serpentine fishes. Again, discovered in 1991. Mesoplodon peruvianus, 1991. Again, another species of these mysterious beaked whales. And it was discovered as a carcass lying on a beach. So we're still discovering large animals. Well, we've discovered them in the past. Can we know necessarily that we've discovered them in the future? Well, yes, we can, because I can demonstrate that by a method that biologists use to actually work out how many species there actually are. I need a volunteer at this point to go on a deep sea fishing expedition. Who wants to go on a deep sea fishing expedition? You want to go on a deep sea fishing expedition? Okay. So, that's a No, it's not a magnet. It looks like a magnet, but it's actually a very high-tech deep-sea sampling device. No expense spared. Oh, yes, yes, yes. And what I want you to do is to use this high-tech deep-sea sampling device to work out how many different sorts of animal there are in the sea. So this is the sea, and it's filled with lots of different sorts of animal. And so we're going to use a technique which ecologists use to actually work out how many species there are actually present here. So what I want you to do is to, don't look, because if it's really, if you're going to stand there, close your eyes, and then take the deep sea sampling device and drag it along the bottom of the sea here. Okay? And we've done that once. With the magnet. And
deep sea, you said it's a magnet.
Yeah.
It's a magnet.
How many different sorts of animals have we got there?
You've only got one sort, two sorts, three sorts. Sorry, you only got three sorts, otherwise four.
I think you miscounted. Three sorts or four sorts?
You got four sorts.
Four sorts. Okay, yeah, so throw one back. No, just the one just the one that's got swapped. That one, yeah.
Got double that.
Yeah, put that one back in. So you had four different sorts the first time, please. Okay, I'll try it.
What should you do? Just take it off your hand.
Okay, that's great. Okay.
Okay.
How many new sorts have you got this time?
One.
There's one new sort. You've got one new sort this time, okay?
This is fun.
One new sort? Yeah, one new sort that time.
What's that? Interesting.
Oh wait, but you do it with your eyes shut, because that's the whole point. If you're under the water, you can't see what's there. So you can't go looking at the Well, I wouldn't do that because you'll take the eye out of the water.
Don't worry, he's got another one.
What, another eye? Okay. How many new sorts have you got? Every time you see how many new sorts of
Sorry,
animal are.
you're very unlucky. You didn't get
That one was.
No.
Yeah, the other those. That's it. So that's one new one. How are we doing? Let's just have a look at.
We haven't got that many.
Yeah, we'll do it a couple more times.
Hey. Cool, we're getting around. That's awesome.
Okay. So how many new sorts have you got this time?
Ooh, we got a new one.
Okay, wow.
It
Yeah.
has new differences on it.
Yeah. That's my angry fish. Hammerhead shark.
No.
One of those before.
Dolphin!
So two new ones. Okay. Well, again, you don't want to choose because so nothing that time. Okay, another go. You better speed up slightly.
I'm going extra slowly so I get what?
No. That's it. Remember, you can't see what's going on because it's the deep sea. Okay. What have we got? How many new ones have we got?
Well, we got that.
Yeah. Okay, one that one. So there should be.
This is fun. I should do this more often.
Get a green bar. No new ones that time, I think.
No.
Yeah. Okay. A couple more times.
Is this what you do? You get a stick with a magnet.
Well, hold
dip
on.
it
It's
into the
got
sea.
like a big sweeping device. Okay.
Oh wait, no, that one fell off.
So that's a new one.
Yay!
So one new one on there. Okay. I think that's the final time. Is it? Yeah. Yeah.
No.
Okay.
Okay.
Any new ones?
I can't see.
No, no new ones that time. What's your name?
My name is Finn.
Finley. Right. Okay, Finley. Here's our graph. So our graph has, on this axis, we say that's the number of goes, and on this axis we've got the total number of animals discovered, different sorts of animals discovered. And as you can see, it started off quite steep, and then it slowly got flatter and flatter and flatter. So, we saw at least 11 different sorts of animal. How many people think that's all of the animals in the bottom of the sea? No, so there's more to discover. So let's do a little kind of vote here. Who thinks there's no more animals to discover? So vote now if you think that that's it. There are only 11 species. No one thinks that. 12 species. So there's at least one more. Okay, who thinks there's 12 species in the sea? Okay, 13 species, 14, 15. You've got to extrapolate. Take your mind's eye and see how far it goes. So we had some 15, 16, 17, 18, more than 18. Okay, well, you're very much optimistic. There's actually 16. You can sit down now, Finley. Thank you very much. Give a big hand for Finley. So by using this method, we can estimate how many different sorts of animal there are in the tub there, or in a different application, we can use the rate at which human beings are discovering new animals to predict how many new animals are left to discover. And we can do this globally. Okay, if we can go back to the slides, please. Oh, there we go. So here's a similar curve, and this curve is for large marine animals worldwide, how many we've discovered over the last 200 years. So on the x-axis, we've got the number of years, and on the y-axis, we've got the cumulative number discovered. And the blue line is the black line is what we actually see in the historical record, and the blue line and the other coloured lines are my efforts to try and fit a decent curve to that. So by taking that line, we can extrapolate and work out how many animals there are to discover. Well, it depends on how you do it, but there probably are at least 4 or 5 animals awaiting discovery by science. And that's animals in the open waters. We're not talking about going down to the bottom of the sea and on the deep sea floor. That could be a whole new ballgame. Not only that, we can use this method not only to say, well, are there lots more animals awaiting discovery worldwide, but are they of particular sorts? Could they be the animals without backbones, the invertebrates? Could they be the sharks and the rays? Probably are a few more sharks and rays. Could they be big bony fishes? That's like your tunas and swordfishes and things like that. Or could they be new species of whale? And it appears that maybe there are some more sharks and species of whale to discover. So this is evidence for monsters, not physical evidence for monsters, but mathematical evidence for monsters. So maths can be way more fun than those of you who didn't think it would be very fun. We can use it to discover monsters. Now that's an application I'm pretty sure you hadn't ever thought of before. And not only that, we can also say where in the world these monsters might be found. This line here is for North America. This one's for South America. Looks as if there isn't that much more to discover in North and South America. This one is for Africa. This one is for Europe and Asia. Maybe there are some freshwater animals to discover still in Europe and Asia. Maybe in that big lock, only a few, well, less than a kilometre away. But the best place of all, if you want to find freshwater monsters, is actually, you want to go to Southeast Asia, Cambodia, Vietnam, Thailand, because they're still discovering large freshwater animals. They discovered only in the 1990s a massive species of freshwater stingray, really big, over 2.5 meters wide. And that tells us that there's probably other animals yet to discover. And Australia, maybe there's more things to discover in Australia, but not in South Australia because all their rivers are drying up, maybe in North Australia, and above all, Papua New Guinea. So, the answer of the question, are there unknown species? The answer is yes. Then the next question is, are they actually seen by people? And that's a more difficult question to answer, because certainly lots of witnesses see things. I know Adrian's going to be talking about this in a moment or two, but again, we can use statistics to help us understand about people seeing monsters. And I've been spending some time looking at the reports from Loch Ness. So what have we got from Loch Ness? Well, we've got probably about 1,900 different reports, and they represent about 1,400 different distinct events. That's where different groups of people saw the Loch Ness Monster. Most of those reports, they really started being reported in the 1930s. Even if they said they'd seen them when they were children, witnesses said they saw things when they were children in the 19th century, they didn't report them until the 1930s. But I'm a statistician, and that means I have to do a few little tricks with the data to make it kind of analysable. But having done all that, you can find out interesting things about the Loch Ness Monster. Or maybe not the Loch Ness Monster, but about the people seeing the Loch Ness Monster. Anyway, these two graphs tell you about when people reported seeing the Loch Ness Monster. And the top one is the year they said they saw the Loch Ness Monster, but the bottom one is the year they reported seeing the Loch Ness Monster, which is slightly different.
How do you know they saw it?
Well, they reported it. They didn't, I don't know where they saw it, but they definitely reported it. But I think most witnesses tell the truth. They definitely thought they saw the Loch Ness Monster. So we can see a big peak, 1933 and above all 1934. 1934, we know, as I've read the pages of the Inverness Courier, there were traffic jams around the loch because the Loch Ness Monster was so popular. And again, there was a peak in sightings in the 60s and early 70s. So that tells you a little bit about the history of the loch, and we can divide those sightings up into first-hand sightings, where you've actually got the records of the witnesses themselves, and second-hand reports, perhaps where they were reported by the newspaper. And we can say other things. When do people see the Loch Ness Monster? In the summer. Does this mean the Loch Ness Monster is most active in the summer, or does it mean there's more tourists to see the Loch Ness Monster in the summer? When do people see the Loch Ness Monster during the day? Well, mid-morning and mid-afternoon. There's a dip at lunchtime. Draw your own conclusion. And this is the interesting one. What are the weather conditions when people see the Loch Ness Monster? Overwhelmingly, when they describe the weather conditions, it's very, very calm. And I'm told by people like Adrian, who spend a lot of time on the loch, that Loch Ness is seldom calm. And so there's something interesting going on there too. So what's the take-home message? I think the take-home message is this. You might think maths is really, really boring, but actually we can apply maths to lots of different topics, including monsters. And we can use it, and it can give us great insights into these quite strange topics where you wouldn't think maths could actually be applied. And even strange things, scientists often say things like, anecdotes are not data. You can't use anecdotes. You can't use things like the reports of the Loch Ness Monster to reach interesting conclusions. Yet, I would argue, under special circumstances, you can. We can use these Loch Ness Monster reports to tell us about the conditions under which the Loch Ness Monster is actually seen. So I think, that's the story of statistics and the Loch Ness Monster. Thank you very much.